Assalamualaikum warahmatullahi wabarakatuh. This video is about operating principle of a transformer. You can pause the video to read the note here. Now look at the transformer itself. First of all, we have an alternating power supply. As we know that alternating power supply supplies current which changes direction for each half cycle. So let us look here. This is the first half cycle of the input. For the first half cycle, current flows through this way. Okay, and then it flows in the coil here. So what happens is electromagnetic field will be generated around the core. This is what we have learned in previous video. Okay, we have learned this one before. So the same thing happens here in the primary coil. So magnetic field will be generated around it like this. Okay, and then the magnetic field will be transferred to secondary. Okay, this is secondary coil. So we have magnetic field also here. So I can use this as the magnetic field. So you can see here, magnetic field will be generated here also because it has been transferred from primary coil. Okay, so you can see here the voltage keeps changing. It increases, decreases like this. So what happens now is the magnetic field is cut by the coil of the secondary coil. So this is what we have learned earlier. When the magnetic field is cut, we say it is the magnetic field is changed, or changing magnetic field can induce current. So induced current will be produced in secondary coil, and then it flows out of the secondary coil to CRO, and CRO will show the reading. So you can see here is the output of this step-up transformer. So initially the voltage is 2, now the voltage is 4. This is still the number of turns here. You can compare primary and secondary coil. There are more number of turns in secondary coil. So what happens in the second half cycle is this one. You can see. Let me change the color. Okay, this is the second half cycle. So current flows in opposite direction. You can see opposite direction. So as a result, the polarity of the electromagnetic field will also change, and then now it flows in opposite direction. This is the magnetic field. It is transferred to secondary coil. The same thing happens here. So we have the changing magnetic field also in the secondary, just what I have explained earlier. Okay, now you can see it grows and it collapses, grows, collapses. So while this process is happening, it will cut the secondary coil. As a result, induced current is produced here. Now it will flow in the opposite direction from the secondary coil, from the first half cycle. So here is the direction of induced current. So we have the output here, and the output is bigger than input current because we are using step-up transformer, and the number of turns in secondary coil is more than primary coil. As a result, we have a bigger output. So while you are writing the note, please pay attention to the keyword that I have underlined. You can see here, you can see over here. And don't forget the word induced EMF. Okay, you cannot simply say current or voltage. You must include the word induced in EMF or induced current. Okay, this is for step-up transformer. Operating principle for step-down transformer is just the same thing, but the difference is only the number of turn or primary is more than a secondary coil.